Welcome back to Made Up of Wires, where we are decompiling New Super Mario Bros. 2 or Symphony of the Night. We'll do Symphony of the Night. Go to soten.z.dev to learn more. For the first time on the stream, we are also multicasting to YouTube. Hey YouTube. Hey Twitch. What do we do here? We decompile Castlevania Symphony of the Night most days, and that's what we're going to do today. Maybe play a little bit of the game. We'll see. We were working on Reverse Castle Keep towards the end of last week. Quick announcement. This is, actually last Thursday was, the 1-year anniversary of Made Up of Wires. We've been doing this for a year. And how far are we? Quite a bit further, honestly, than we were when we started. So let's look back at July. We had almost finished DRA. It was getting close. DRA actually wasn't finished until later, and I guess at the beginning of this year. Richter, where was Richter? Sitting at about 90% done. Weapon, we spent a long time doing weapons on this channel, and it had quite the countdown to get weapons done. Sen was one of the first overlays to be finished, but wasn't finished quite yet. The stealth drop of Abandoned Mine. Lots and lots of overlays that have gone from nothing, like Lib, to being finished. Even Mad, the debug room, not nearly as close as it was, and we finished a bunch on here. So at the beginning of the year, spent a long time on Doppelganger 10 and 40, and this summer just finished Top in a relatively quick time span, less than a month. Oh, I don't know what. I don't know how these graphs work. It's not my page. Well, my. Excuse me. I'm a contributor to the project. It's not my project. I just like decompiling. And that's what we're going to do today. Show you what I've been working on. I've actually gone back to Doppelganger 10 and 40. So those have been done for a little bit. We finished those back end of June, beginning of July. But there is more to do with them. So I mentioned last week that I've been working on something called our Peachy build. If you say it fast enough, you might understand the reference. And I have lots of tabs open. And why do I have so many splits in my window? Because I've been working on getting as much of the data imported into BO4 as possible. So we have a portable build that we do as well. But until all the data is available, or you can fake the data, and all of the code is decompiled, these builds won't work. So these builds help ensure that as we decompile, we're decompiling cleanly. It helps find issues that may be masked over due to architectural differences. So for example, on the PlayStation 1 and PSP, they're 32-bit systems. A 32-bit pointer versus a 32-bit integer may look the same. We may be accessing offsets as fixed differences between fields, when in reality they're structs, and we need to account for pointer size differences on different platforms, and that'll be more relevant when we get into some of the other systems, Xbox 360, for example. I also spent a little bit of time, so we can look at the data. I actually added some the data progress to the GitHub page too. Well, I don't know if that's worth submitting yet. I need to talk to people on Discord about that. But how much data is there? There's a lot of data. A lot. And I'm not all the way done yet, and unfortunately our tooling doesn't support all of the things needed by Doppelganger 10 and 40, and so I'll have to muck with some of that as we go. So there are some interesting things that I found here. So we have these pose macros that build pairs of 16-bit values. There are commands in here that apparently haven't been seen before, and it's not clear. I haven't looked at what those do yet. We could take a look at that. But basically I've been going through, and let's pull out the splat config and look at that. How much data do we have left? So to find the data, we're going to look for sections that are just data without the dot in front of them. We have this one here, only about, let's see, that's hex 200, we'll just say that. So what, 256 bytes-ish left to go there, and then a bunch of data at the end. This one's a little rougher. That's about 6,000 bytes. Unfortunately, these are a type of animation frame that we do have tooling for. However, there's a flag that's unsupported in our tooling currently, and we have to deal with that. One fun thing, though, that I did in our Soten Assets tool. Soten Assets is our tool for taking some of that data that's in a stage or a boss and extracting that without having to do all the work manually. This will be valuable later, I think, when we are looking at more tooling to, say, put in a disk on a PC or a Mac or whatever, and then be able to hit play, and data comes, you get to play the game locally with your current disk. We need tooling like that to be able to pull some of that stuff out. In this case, the tooling was looking at the header file for the overlay, but for Doppelganger 10 and 40, both of those use a lot of the same information, and so they use a common header file. And when this was kind of naively just reading a single header file, it wasn't looking at any of the includes or anything like that, which are processed recursively. So I switched that to use the C preprocessor. And now when you pull that in, it expands all the macros and does all the things. And that actually worked out fairly well. There's a couple other overlays using this, and they all continue to work fine. I do have to go format that. I'm gonna shut this down though. A lot of stuff open. We can close those. Check my Git status. And I added this Doppelganger anim. I am going to add that to the CMake lists. And we'll try a build there. It's not going to succeed, but I want to see if there is much left to do here. Oh, extra elements in the array. That's interesting. So my arrays are not the correct size. That's fine. This is interesting. So I need a forward declaration of this. Let's try this. This is something. Normally I would do this in C and not really think twice about it. But when you're trying to do a matching decompilation, you have to make sure every variable is in the right order. You have to make sure every declaration is correct. Okay, and that just noting that there's a forward declaration for this. Because these, for example, above, these are going to be stored in the BSS segment of this overlay. We don't want this we don't want this there. So let's see if there is what I have to add. There's some things that got picked up from other overlays. We want to add that. Don't want that. All right, and we'll keep going with top then. All the config, I will overwrite that. I am going to rebase if I can. And we will grab RTOP as well and rebase that, and then we'll build and see what we have for RTOP. RTOP, I've mentioned last time that it should go relatively quickly. We don't have too much difference between top or castle keep and RTOP, the reverse keep, which is why I chose it. The other one that's in this area that is probably worth looking at, but maybe a longer effort, is BO6, which is Richter. It's going to have a lot of overlap with Castle Keep, but so should RTOP. And we are building, and that all looks good. So let's look at where we were. I haven't looked at this since last week. So we did the initial splits. Most of these are not using shared code yet. They're still just including ASM. We have our new C files, which are this 2038, 204E8, 2D57C, and 2F858. So those are where we're primarily going to be looking. So let's look for include ASM in source stage RTOP. We'll look at US and everything that starts with a 2. And that is what we're left with. 22 functions, and I'm going to use find again. I do think we have some matchings already. Oh, we don't have matchings. We did work on one yesterday or last week. Let's do Clock Tower 3D since we have that for top. Maybe that will be a relatively quick one. The Clock Tower functions are kind of interesting because they have a little scripting language that builds the clock tower that you see in the back. So let's do that. I use a script to copy this locally. Assembly is extracted to ASM US, and then the same paths as basically the disk layout, but also the source layout. These are going to be a non-matching 2F85. Oh, not top. RTOP. I will move this to a file called, I think, eClockTower, which should have its equivalent in top, but we'll work on the the code here first. We're going to do this in decomp.me, which do I not have a tab for today? Decomp.me is a collaborative text editor. Decompilation tool. Let's put the function signature entities in Symphony on the Night have a function signature entity star. We usually call that self, and that when run through M2C, which is a decompiler, will give us the correct structures and variable names and fields, or should give it a hint. I don't remember enough about the clock tower to know if there's a jump table here, but my guess is there is not. I'm pretty sure this is the same implementation. So we're getting a bunch of M2C errors. M2C, again, is the decompiler. That's because M2C doesn't know the PS1 SDK macros. And I've mentioned this before, but it really should understand these instructions, but it doesn't. So we have some errors here. I'm going to ignore most of that for now. And we actually have other very recent version of this 99.76%. We're going to grab that. I'm just going to grab the whole thing. And what we're going to see is whether or not this matches, how well it matches. And then we can map some of these globals to names that we know already. So Clock Tower data and Clock Tower data 2, we don't know what those are yet. We're getting errors about those. var s3 is undeclared because it doesn't know about that data. So this older one from 3 weeks ago, this was from top. It's going to have those structs in it, and actually has all the macros we need as well. And so I'm going to grab all that from the top context, throw it into our context here. And we're at 98.93% then, which isn't bad. We have a few macros here that are getting redefined because our default context excludes the definition. Not sure why, but we'll get rid of those other ones. Oops, what did I do here? I don't know what the advantage to doing that is. The way that the context is created was before my time. And mine is not to question why. The way that we dealt with this the first time is by using the PSP version, which is mostly the same, but we also have the ST0 version. Hey Nate, good to have you back. And we're at 98.93%. That's pretty close. We have some constant differences. We have named globals in the top version versus our unnamed globals. We'll go through and name all those so that those work fine. And then RTOP is inverted from top. So some of our dimensions here are going to be different. So we can go through and fix those. Our positions are all going to be backwards from the original. So I'll go through and just find which of those there are. It looks like 64. Maybe 800? Yeah. Nope, 90. $800? Looks like something like this. I'll get there eventually. These are inverted. Odd to have them out of order, Y then X, but that seems to be what it is. And same there. No. Let's try, instead of doing a plus equals, doing just the addition here. I don't think it's going to end up being the same though. No, still odd. So we might have to go to the PlayStation version for this. Odd that these are coming up different. We'll come back to that after we get other things resolved. Everything else looks fine, actually. So we have a few issues down here to deal with. What I'm going to do next is take all these globals, and we're going to add entries in the symbol table for them. And so then when we bring this back over, it's going to be, those symbols will be ready for us. And decomp.me makes this easy. We have what we're compiling on the right and what we're looking for on the left. And so when we have a symbol that differs, they show up as differences, and the automatic global variable names have the address in them. So it makes it pretty easy. It's possible that the data for these is going to be different from top and ST0 because it is inverted. I don't know yet. And if I can find the no clip address again, we can go over to RTOP and try to identify the other things that are unnamed. There's gonna be some enemies there that you may not have come across before. All right, so that looks like all of those. So really now we just need to figure out what the deal is with these. I have all these bars that I didn't get rid of. Get rid of all those. All right. So the last thing that we have to deal with is this. So we do have a 0 in VX. And we know that because we're storing the 0 register into offset 10. But we're loading an 800 into V0, and that's being stored in VZ, maybe? Is that correct? There we go. I just needed to read. That was what was missing. So we have all of our globals. 1, 2, 3, 4, 5, 6. 6 of them. Great. We have a bunch of macros and other things like that we're going to need down at the bottom here. These come from the PlayStation SDK. Some of these others are going to come from... We'll see where they come from. But we can go over and try to get this into... this file. So first we're going to grab all that code. We're going to include RTOP.h. We should have an RTOP.h here. We don't yet. So let's make one. Give it a license. Here we're going to include stage.h. And what else do we need here? Let's go look at tops. Clock tower? Yeah. So we have a cloud struct and a common clock tower header file. I think that should be enough. I think that should have our clock tower data and clock tower data 2, as well as all of the other macros. So let's try building that and see if that works. So something failed. So our splat command failed. We're going to get rid of the dev null. And it looks like we have duplicate symbols. Easy enough. And fortunately, they are to the same place. I think, oh, great. Yep, that all worked out, and we're building fine. All right, so we have Clock Tower 3D. Likely this other one is clouds, and we could figure that out pretty quickly. The code for this was identical to the RTOP code, except for these offsets. And so we need to decide, do we want to keep the code the same, or do we want to, do we want to duplicate it in both overlays? Do we want to maybe have if anybody else needs this, do we want them to define some macros that say what the default offsets are for a bunch of these things? I'm not sure. I don't know what the best way to go about it is. Right now I'm fine, I think, with it being duplicated because we have tools to identify that. So that is fine. What else do I want to do while I'm here? Awesome. Good to hear, Nate. Have you used WSL2 or Linux recently? Get yourself a WSL2 environment and get going. We can I can cover that actually. I did that I think back in December was the last time that I did it, was basically setting up your Soten dev environment. Why is my my load, 11.3. I'm using this development box to also share a screen with my Mac, and I had to get rid of the NVIDIA drivers lately due to some things, and I haven't reinstalled them. And so it's just doing software encoding or decoding of that AirPlay stream, and it is taking some work. All right, so the next thing that I think is worth doing maybe is looking at the clouds function and making sure that that is the clouds function. Should we do that? Let me see if I can find yeah, so I have the no clip offset. Oh, Kernel Equinox. That's who did Soten.dev. Is that right, Nate? I think that is... It looks like I found him on Reddit. He was doing a ton of Castlevania hacks. You did one of the level editors? Okay. Is he responsible for Soten.dev as well? Now I'm going down a rabbit hole. It's like he's working on Alarmo stuff lately. Oh, if you didn't get your Alarmo, too bad. The price has gone up. All right, so I'm going to go and let's get DuckStation going. We'll get into RTOP. Maybe reset. So last Thursday, I think it was, we were looking at Game Shark. Wednesday or Thursday, I can't remember what. We're looking at Game Shark codes and what that meant. What is a Game Shark code? And how they affect decompilation, what we can learn about them from decompilation. I have a bunch of breakpoints here. I'm going to drop those. I'm actually going to, I think, just reload my state. Which is right before the Richter fight. I'm going to leave the room. And I am going to re-enter the room with and pause. We're going to re-enter the room with clipping enabled. Or no clip enabled, I mean. So I should be able to L2, yeah, there we go. So that should, yeah. Oh no.
No. What have I done?
Thank you, Alucard.
Yeah,
for
I should move
saving
this
Richter.
over. There we go.
Alucard?
Thank you, Dig Down Deep, Batavia.
The same Alucard who fought alongside
My
my
no
ancestor,
clip didn't.
Trevor Belmont?
not
was
clip.
over 300 years.
Do I have to leave the area? Or leave the room first? Let's try that. So I do have to re-enable no clip. Let's get in the room. And no,
No. What have I
still getting
done?
triggered. Oh,
Thank you, Alucard, for saving
it's not getting
Richter.
triggered. It was just the cutscene at the end.
Alucard? The same Alucard who
All right,
fought
that's fine.
alongside my ancestor,
Good
Trevor
evening.
Belmont? That was over 300 years ago.
No time for small talk. Is the person who controlled you in that castle over there?
Yes.
Hello,
I
Tom
think
Travis.
so.
Good to have you.
Maria, take Richter and leave here. I'll finish.
I don't
this.
have YouTube chat
All right.
overlaid. Didn't figure that out yet. So, I'm not just talking to myself. So we're going to go to the reverse castle keep. What I want to do is we're going to set some breakpoints for the entities that we don't know yet. And then just want to look at some of the... I do have double jump, but I don't have gravity boots. So let's do that. Let's go through and... Hey, Sander. Yes, so we're looking at just the beginning parts of the reverse keep. And so we have a bunch of functions. We don't know what they do yet. We haven't decompiled them. And so it can be helpful to try to associate some names with what those are. When you're decompiling, you get a general idea of what they are. So let's look at what... Where's my find? What they are. So we're going to grab these addresses, and I'm just going to go through. I did know that Alucard was Dracula spelled backwards. Did you know that Zorlo is Ulrock spelled backwards? If you know, you know. There's a great what's the Secrets of Castlevania video by Dinner Dog that goes through Zorlo's relationship with Ulrock's. So some of these I'm going to put in maybe 6 of these, because too many will just be hitting breakpoints all the time and not be able to find anything. So as I hit these, we're going to try to determine what we're seeing on the screen that might be that thing, if we can, and then add some comments, and then when we come back later to decompile these, hopefully we know what they are. So let's move that off screen, of course. Sorry, moving things around. I set this up a little different so that I could have all the windows on there. So when we get to something that we haven't seen before, we're going to hit a breakpoint. This BF4 breakpoint is getting hit. Some of this, I'm guessing, is going to be like the staircase and things like that. But we have hit this BF4 breakpoint here. I am gonna go over and make a comment about that. Because my guess is that it is probably related to that staircase, or I don't think the button exists in the reverse keep. We'll see. We'll see. I don't necessarily remember what I don't remember or not. So we're looking at the 0BF4 function. So then we're gonna disable that one, unpause, and keep going. So we hit another already. This is B48. This is the one right above it. So let's go over and look at top. So we have secret stairs, and then a so this is hitting the panel that's above, like the destructible blocks above the secret stairs, and then the switch beneath those blocks. My guess is that is what these top three are as well. So we have the secret stairs, the blocks, and then the button. So we'll get rid of that. And so the button entity won't exist. Oh, it does exist because those are destroyed already. The stairs are down. I don't think that there's anything up here that makes that much of a difference from an entity perspective. All these are going to be things that we've seen before, breakables and items. Bonk. So let's get out of this room and into the main area. Okay, so we have skeletons that are, when I play with the analog stick, I always item crash. So nothing in here yet, and there's no way out of this room. Otherwise, I have to leave. Gravity boots would be nice. But I bet I'm gonna go over here. Oh, come on. One smash. I don't remember what... Oh, giant skull. That is an enemy that we would have seen already. So that'll show up in code that was previously duplicated. We're just looking for, hopefully, things that are unique. Let's go up here. I don't recall what's up here. It's been a while since I played that. So the jumping tombstones may be in a different part of this code that we haven't covered yet. I don't think that those are in the regular castle, the upright castle. What are we gonna get here? A garnet. So let's go over to the elevators. We should be able to find those as well. Oh, there is no There's no lion elevator. It's possible that the code is still there for the lion elevator, even though it doesn't exist. And I'm not going to be able to get back up through that hole. I run out of mana. I can get up there. Do these elevators? Yeah, these elevators are there, but they're not in my list either. All right, so now we're up here. So there's a bunch of stuff still that we have not seen yet. Let's see if we can... Oh, I'm cursed. See if we can find the tombstones. So none of the functions, though, that we have as breakpoints are... They're okay. The duxation tools are okay. I wouldn't say that they're really good. There are things that I would like that don't exist yet, and I just haven't spent the time yet to deal with them. So B4 was our the last one that we did. So we're just going to keep going up and adding each of these. Yeah, I think Biz Murphy uses no PSX, and I forget what was stopping me from using it. There were certain things that I found just easier to set up and get going in DuckStation, and then I kind of was stuck because I understood the way that it worked. And I'm lazy. So I'm going to add a bunch more of these. It would be nice to be able to find the tombstones, because I don't think we have that one yet. I'm genius. I'm not. I like comfort and things I'm familiar with. I just happen to be familiar with some of these things. I was having to do some Blender work for a friend, and I'm terrible at that. That's why I don't stream any of that stuff. I'm guessing by this point we've hit one of them, that is the tombstone. If we don't have it already. I'm guessing we have it, but let's find out. I'll just add them all. This might get really noisy, so apologies if I can't find anything this way. Usually I don't like adding so much. One of these is going to be clouds, too. Shoot, I should have... Where was... F858 is going to be clouds. So I should get rid of that one. It's going to be a relatively large one. Second to largest. I don't want that. That will definitely trigger. Last one. All right, so let's see if one of these is our Tombstone. Okay, we triggered 4E8. I'm gonna turn 4E8 off. And we'll keep going and see if that's it. 57C. Turn that off. So 4E8 or 57C. So it's one or the other. So I'm gonna kill all the tombstones. And then we'll go and turn. Oh, there's more! How many of you are there? Then we'll turn this on. It's like a backdash. That would make sense. Okay. So I'm going to turn 57C back on. And see if we see anything. Oftentimes, as well, there's functions that work together or call each other. So it's definitely possible that those are like a cluster of functions as opposed to unique entities. So all the tombstones are gone and 57C is no longer being called. I'm going to assume then that that is related. Let's look at the 4E8 as well. Go back over. 4E8 is still being called. So it's possible that 4E it wouldn't be like the ramps. 4E8. So let's look at what else is over here. Oh, it's possible that it is would the giant skull look at that. That was pretty cool. So 57C, I'm pretty sure is the tombstone, living tombstone. Reference. So let's get that one. 57C is in this file. And in a roundabout way, we can figure out what this entity is. Where is this? It's not that big. Let's decompile that one next. Let me unpause that. So this one should be new. I don't think that we've would have had this previously. But I'm going to do this the same way as the other one. I just know less about it. The things that I do know is it's going to be an entity update function. So it will have that same signature. We don't know what the entity IDs are yet. So I am going to get rid of all this other stuff from the context that was top related. And change the argument there. And we'll see what we can do. So we have a bunch of so I screwed up my context. Okay. Try to fix that. Seven, 2, 5, 5. Is that what it doesn't like? Oh, no, that was fine. It's the voic. Not many voic functions in the world, usually void functions. We're going to get rid of all of the function references. Usually those don't make a difference. If you're not familiar with C, the way C works is if old C, when Soten was made, you don't have a reference to a function. I'm going to guess this index is 256. We'll figure it out when things are compiling. If you don't have a declaration of a function that you try to call, it assumes all the arguments are integer size, and it assumes that it returns a value of integer size. That just kind of works out in most cases and compiles the right thing. The PSP is much more sensitive to it than the PlayStation is, so we do have to be a little careful, but it's really only if we can't figure it out otherwise. So we have this unknown collision function 3 that we are going to look up the signature, not because we need it, but because we want the type of the argument. It takes a signed16 array, so we're going to make that this. And we're compiling. So I guessed correctly, our offset for G entities is plus 1780 when we're at 256. Not really a huge accomplishment. It's just something I've seen many, many times. MV1 goes away. So what I'm going to try to do next is remove as many of the local variables as possible. Some of them are legitimate and we need them, such as the return value here. We'll call that entity. Most of them are not something that we need. I would like to invert this, and we'll see if that works. No, we can't, because we have to destroy the entity regardless. Okay. That's interesting. So whatever we're doing here, basically this is a placeholder entity, and we're coming through and we're creating something else. We're creating entity ID 2. Usually, we could go see what that is. We have to go down to the entity update functions. It's 4E8. That's interesting. I'm pretty sure that's the other function that was in there. So when we get to 57C, we're coming down and we're creating a 4E8. Whatever that is. We'll figure that out in a little bit. A little strange, too, that these are so early in the entity list. Usually we have things like breakable and explosion, but explosion is later. So not terribly common to have not breakable early on in the entity list. A little different. But that's what we got. Our 5cc, we're going to make that an E in it. And then get rid of a reference. I want to see if are all of the cases in our switch, do they do anything afterwards? No, so I'm going to change all the returns to breaks. And then get back to deleting. So if you're not familiar with how any of this works, how we do decompiling on this project, Splat or SPIM, Splat using SPIM is going to come through, find function boundaries, and then provide us with a disassembly. And the disassembly is what you see here in the middle column. That's relatively easy to find. We find things where we're adding something to the stack pointer, an instruction where we're adding something to the stack pointer, and then something where we're calling JR or jump return with the RA register. And then usually it's a no-op afterwards, but it doesn't have to be. But typically it is a no-op immediately afterwards. There's something called a branch delay slot. You don't need to know about any of that. So those tools come through, they find the function boundaries and give us a disassembly. And they do some nice things too, putting symbol names in where they need to be. And so we can take that disassembly then. We know that the PlayStation 1 version of the game was compiled with an old version of GCC. Through experimentation, we figured out what options need to be set to compile things back to produce identical code. And so we take that disassembly, give it to another program called M2C, Machine to C, which generates this initial decompilation. And we take that then and finesse it until we can get something that matches completely. And what we have here is actually pretty good, but along the way, what I like to do is try to get this to be even better. And that can be done in a lot of different ways. Some of it's making the code more readable. Some of it is correcting ordering and other things. So somewhere around line 50 down here, we see that there is a difference between how our code is compiling and what code was originally in the game. And so we need to figure out what is causing that and then fix it. So that's what I'll do now. So we have this temp v1 underscore 2. It looks like what we're doing here is doing a pre-decrement. And so this is a pretty common as well. It looks like this is a timer. And so every fourth frame, we're going to do some rotation when we're in this state. And I like to try to make the code look as logical as possible. And if that also makes it look more correct, great. So in this area, what it looks like is this is pretty common as well. We don't have a temporary variable here for assigning var x. What's happening is we're just assigning it, or sorry, velocity x. We're just assigning it directly. And GCC, when it comes through, it tries to optimize by doing that. And then our code starts to match. So it looks like this isn't quite right. What I'm going to do is change this to a post decrement. And then do an explicit check against 0, or we could try the not. Was this not being reassigned? Sorry, we'll look at, we can always get back to the original M2C by going to the decompilation tab. Yeah, we're assigning back right here. So this is a decrement. The shift is not terribly important, but I'm going to set this equal to 0, or do the comparison against 0 and see what that does, if that cleans that up at all. Not quite. somewhere here we are loading a 1. Not sure why that is. Let's keep going down here. There's going to be some issues down here as well. This is kind of similar. It looks like we're doing a mod, maybe. And then setting the current animation frame. If the velocity is less than fixed 2. So let's do that. Actually, not a mod. I think it's a ternary. Something along these lines. Not quite. Let's back that out. So not quite what I was expecting. So let's look again and see what we're doing. Velocity X. So velocity X is a 32-bit fixed value. Fixed is a SOTN data type where we use 16 bits for the integer portion of the number, 16 bits for the fractional portion of the number. When we do this OR I, we're actually only looking at the bottom 16 bits, but that's for V1, and V1 was originally this 4 up here. And where is that 4 coming? That was the AND up here, which also seems to be missing. Hey, Kesner. Good to have you. D2XD2 says, how separated is the low-level CPU, GPU code from the actual game code? It is not separated at all. So basically, if this was going to be ported to something else, that means implementing the PlayStation 1 SDK. And there are some projects that are doing just that and basically implementing the PlayStation 1 SDK on top of, say, SDL. That's likely the best way that this that ports start happening. All right, so I'm not real happy with a couple things here. We're not getting the results that I want. So I'm going to go to the PSP. We haven't imported the PSP version of this yet. So we'll look at that. If you aren't familiar with the project at all, we have the US PlayStation version that we're decompiling. We have the EU PSP version that we're decompiling. The EU PSP version is the version that comes on the mobile, the Requiem collection. Basically every modern release is the EU version. The reason it's the EU version is because that has English, French, German, Spanish, all of those baked in as languages. Those versions also come with the JP version, the PSP JP version of the game, which is a completely different build, but we're not looking at that yet. But the reason we go to the PSP version frequently is because when they built the PSP version of the game, different compiler, it's the MetroWorks compiler instead of GCC, but they did not enable optimizations for the stages. And so the code listings that we get are much more linear, have a lot more detail and data. We can see more clearly how variables are used, just a lot more detail that is available. So we have a tool called makeconfig, and makeconfig is used for importing new overlays. I'm going to import RTOP as a PSP overlay, and that's going to go through and do a bunch of stuff. Find symbols that we may or may not already know. Because these functions don't have names and they're just given automatic names based on their addresses, the likelihood of this being named the same thing is low, but sometimes makeconfig surprises me. So I am going to look just in case. It should be called 80. I don't have an 80.c. It's in top. Yeah, so it's not there. So the way that I find is because these functions are named different things, they're going to have different code in them. Not C code, but machine code. I'm going to look for a unique symbol, and fortunately the sound effect IDs are usually unique enough that they can be found. What am I looking for? Stage, RTOP. Usually those and this was the only function that used that sound effect ID. So fortunately, it was just as easy as that. So in decomp.me, then I can come over and make a new scratch for PlayStation as opposed to PSP. We already have a preset for the game with the right compiler and right settings. I'm going to come down here and fix my, actually get rid of that one. Add an entry there for the function signature. And what we should see is something that's very, very similar, slightly different, but mostly the same. And I'm going to take our code that we've been working on and just obliterate everything that that was done over here. So we're going to see a couple things. We have variables that we don't need, which I said at the beginning. I'm going to go through and get rid of all these variables, and then I didn't do it. That probably may or may not have been helpful. We should see some things as well that maybe are the wrong types or other things like that. Symbols are going to be different. That's fine. Let's go through and see if there's a few more of these variables that we can get rid of. Variables that are declared but never used are not a problem. Here, this was a relatively easy one that I should have caught earlier. This may be different. This may be greater than fix 2, but no, it's not. So let's do less than fix 2. The logic is may look the same, but what registers get used end up being different. It looks like there might be yeah, there's an abs here. That's what I was missing. So the absolute value is a function call on the PSP, but it is a built-in on the PlayStation. So we get code generated to do that, and that's why we see over here the assign it to a register. If that register is less than 0, then negate it. That's cheaper than doing the function call. But on the PSP, we have a function call. And one of the things that is very unique about Symphony of the Night is that even the PSP version is the PlayStation version of the game with some modifications. But there's a whole shim layer that's basically re-implementing the PlayStation 1 SDK. And that's kind of fun to see. So I'm going to do a few more things and clean up some more of these variables. Typically, anything v0, v1 is not actually a variable that will exist in the final version of the function. And the sooner we get rid of those, the better. And we got rid of all of that. So that's great. So we can take this back. We fixed this apps issue. We can take this back to the PlayStation version. So I do this a lot. I flip back between the PlayStation and the PSP version. And it helps when I copy the right thing. But pasting this, come on, there you go. We were at 84, and now we're at 91% similarity between our code and the original. And the goal is to get 100. We won't get exactly to 100 here, but when we compile it in the context of the rest of the project, we will get a complete match. Let's keep going on the PSP side. Line 21, this tells us very clearly where our differences are. Looks like out of order assignment 32. So this is a type issue. Not sure why M2C chooses the wrong. Illegal is a union with all of the different types. Entities have an extension, which is a chunk of memory that every entity gets that it can use whatever way that it wants. And so we think that this is, or I think that this is the jumping tombstone. So this is going to be an entity extension specific to that. Before we write those, though, before we define the structs for those, we have this illegal one that is a union of a bunch of different type arrays, all that fill the entire size. And so M2C can use that. It sees that here's this illegal entry that I can use. And so I can get all the alignment and everything with the types correct. But sometimes it chooses unsigned over signed for reasons I don't know. Actually, if we look at the M2C version on PSP, it probably chose the right one. Oh, it didn't. Never mind. I trusted it more than I should have. Let's go down to the next differences around line 45. Same thing here. The type is wrong. I had this as a equal to 0, but my guess is that it's a not, and we should see a bunch of things fall away. Not only is it not a not, but I think it's a pre-decrement. And how does that look? Then we still have an unnecessary mask. That unnecessary mask is coming from here. M2C, when you're comparing against a immediate value, as opposed to doing a not or an implicit truthiness, adds additional masks and other things like that. Same thing with facing left. It's going to be not facing left. That's not always the case. Actually, it's just going to be facing left. And we may have to switch the order of these. That works as well. And I like to check every once in a while. So we're nearing 98% of the way here. How close are we getting? So PlayStation, we have a match. The code should be identical between PlayStation and PSP. So I am going to keep going and just fix these last couple things on the PSP as well. They won't affect compilation on the PlayStation version, though. All right. So load half means load 16-bit. This is going to be assigned value, I guess. Yeah. Okay. We have this branch here on line 53. Originally, we can look at where these branches are going. They should be returning. And they ultimately do, but they come down here first. So I got rid of all these returns because they seem superfluous, but apparently not. It's not how I feel about it, it's what the compiler says. Is that really what we're doing? Yeah, I guess so. Okay, so now we're 90 differences, or 90 difference units away. What is left? I think that this is a match here as well. We have symbols that we think a function is called alloc entity. Thank you, Jameson. Really appreciate it. But we don't have a name from the original. That's fine. No big deal. That is going to mess with our number, but that's fine. As long as those are the only differences, that's not a problem. And that looks good. So we'll save this, take this back over. We shouldn't have any differences anymore. GCC was smart enough to know that these returns all did the same thing, optimize them out. Here, since we did have all the symbols that we originally based this on, the only one that's wrong is this gentities_224, which is a vanity symbol that we give ourselves so that we can identify this case where we're indexing into that particular offset. And it's not actually an issue. So we're looking for 85.7C. Something to do with the tombstones, I think. So we're going to look at RTOP, which is the reverse keep. And paste the code that we were working on. We are going to change this to import rtop.h. These are generated files when a new overlay is imported. Basically, they include all this. These include ASM macros, which bring in the assembly for the functions that we haven't decompiled yet, so we can kind of incrementally decompile and build, and hopefully everything will be green. And it is. So specifically where we're looking is these two lines. FRTOP is some data and other things like that related to resources needed for the stage assets and things like that. What we're really concerned about is this RTOP, which is the file that we're building actively. And as long as everything's fine, that will appear green. We change something, do something stupid, changing logic like that, and it'll come back and that'll be red. And that's how we know that this is working. What is the time? So we have all these entity extensions that are illegal. We can't. Hey, Deputy Dutch, good to have you. Happy to do it. Happy to, hopefully. Last year around this time, people said, how far or how much more time is it going to be? And I said a year. And this year I say it's about a year. So we have a bunch of these illegal entity extensions. I'll show you what the entity extension structure looks like. It's a huge union. Basically, every entity can use this field in the entity structure to be whatever it wants. And so you'll see a lot of familiar things: subweapon axe, Vibooty crash, bunch of different weapons. Ghosts, very familiar. Stopwatch, all these things. So we need to create a new entity extension specifically for what seems like the tombstone or something related to the tombstone. I'm still not sure, looking at this, what we're doing. So if the entity exists, we're going to create a new sub-entity, which was that that other function that was triggering in the area. The only thing that looks tombstone-y to me is this check. So if we're 64 pixels away on the X dimension, then we're gonna play a sound and jump to step 3. And then here we're jumping and rotating and doing all kinds of things. That seems tombstone-y. So I think we're in the right place. Let's look at those sound effect IDs and see. There has been a bunch of work done to catalog all these sound effects, which has been incredible. Explode echo. Make sure that's correct. Do like I have a personal goal to require including the sound effect header for the files that use it, because right now it's included by everything. And so when you change sound effects, you have to recompile the world. 65B is our other one. FM explode. Let's go back and see. Dragon Blitz actually is how I got into this comment that he made back in April of last year, I think. I found his videos and was watching his speedruns, and then I think I caught a DB Daily where he just offhanded mentioned the Decomp project. And I thought, oh, I wonder how far along that was. It was actually pretty early on. I'm going to turn down my music here and turn up. Duck Station is already up. Give me 1 second. I want to be able to hear these. There we go. Oh, we're hitting another breakpoint. Which one is it? 13C0. We'll have to come back through and evaluate these other ones as well. Oh, so 13C0 is going to be one of our triangle elevators. With the shadows on the wrong side. That's fun that they're identical. I guess the lighting didn't change in the room, it just is inverted now. Alright, so let's go back and let's listen to, crank up my speakers. I want to hear what these sound like. So 64 pixels is about a quarter of the screen, which seems, yeah, okay, that's reasonable. Okay, yeah, that's an explosion. And let's look at the rotation as well. there's more to the animation than just rotation, though. There is, but it's the shaking back and forth. And so every 4 frames, we're gonna do that jiggle, setting the rotation one direction or the other. Our velocity is interesting as well. So, not terribly. So this is a fixed 4, fixed 2. Oh, it just means per frame, move 2. And then we have a sine 16 timer. I want to see if there is anything that has a timer at offset 80 in this structure. There's actually quite a bit. And are we setting illegal to anything else? I think I have one more thing I want to see first. Yeah, okay, so this is just called Tombstone. Oops, wrong button. So we don't have Tombstone yet. There's a few additional things that we need to do to guarantee that that's what this is, but I'm pretty sure that this is going to be entity Tombstone. So we'll name this while we're here, but let's add a new entity extension first. So at offset 7C, which is where the entity extension starts, we have nothing. And so we use an anonymous struct field. And then at, which screws up apparently Vim's indentation. Then we have a sine 16 here, and we're going to call that timer. Then we're going to jump down to the end of the entity extensions and add our tombstone. So now we have that there. Any illegal fields, we can say tombstone.timer. And we'll just replace all those. Changing the entity extension header. That's a header that's relied on by basically everything. So we have to rebuild the world. Tombstone enemies are they take a lot of hits, but at least their behavior is pretty simple. And that all works. I'm streaming on Twitch as well. And so that get rid of, oh, we still have a signed version of this. That's okay. Or unsigned version, sorry. Yeah, I was just streaming on Twitch exclusively until today. Let's build that one more time. All that works fine. And so I'm not building the PSP version right now, but this code is compiling safely for the PSP. So when that does get imported, this should work without any changes. I'm not as interested in getting the PSP version as the PS1 version right now. Other people are spending a lot of time making sure that all of this imports into the PSP as well. But that's not my focus or goal at the moment. So this is done. We're going to add this, not that. We'll add that and that in those comments. So I want to give this a name that's nicer than Funk US. So we're going to go to the symbol table for this. The existing name is the address that this function is at. So we don't want that extra text. So that will be where our symbol points. And we need, until we decompile and import all the data for everything that references this symbol, which is only one other area, we need to have the symbol table basically as a bridge between our C code and the assembly code that exists elsewhere, or the data that may reference this function. So we'll call it entity tombstone. That's the naming convention that we have for entities, and make sure that that builds. So rebuild all of the C files for this overlay, and that works fine. What we'll see now is if we look at US ST RTOP, reverse top, reverse keep overlay, the data directory, this is all exported data from the files on disk. I don't have these split yet, but we will have a reference to this here in our entity update list. This entity update list actually would be good to name and good to import. Interesting reference here. Somewhere we have a function at this address that isn't named. I'm not sure why Splat didn't pick up on this as a function. Or maybe something wrong. I do want to look at, though, what is this 4E8? Can we go back and see? And is that a karma coin? I think is that a karma? No, it's probably just gold. Too bad, too bad. Yeah, just $1. All right, so I want to enable this 4E8. We hit it right away. So it is something in this room. I'm going to leave the room again. All right, disable 557C. Leave the room. I want to see if that gets triggered before I see yeah, it gets triggered right away. And what about 57C? 57C doesn't get triggered right away. So 4E8 is something else. All right, so we have the tombstone though. That's something. So these entity updates, they're in a table, and every stage has this table somewhere. It usually gets split into a file called einit, and basically these are all of the entity updates for all of the different types of things that are animated or interactable in that particular stage. We have a couple other things afterwards, which are how that data gets initialized as well. So I'm going to do that split now because it's helpful to know about later on. So we're going to look at the RTOP splat config. We know that that starts at offset 4A0. And the tricky part then is we're going to call it, the type is data. We're going to call it init. Now we need to know where it ends. And that could be tricky. Don't need sound effects open anymore. Don't need these open. So we have our entity update functions. Those are pretty straightforward. Afterwards, we have what we call init structs. And these effectively tell the create entity function or other things like that how to initialize data or how to initialize entities when they come up. And so we want to look for how many of these structs do we have. And some of them we know what their names are, like G, init interactable. Other ones we don't. We actually have two here. One of them is never used, and so it doesn't get a symbol, but it exists in the game. Still going, still going. Possibly this 5F0 is also one. There is a way for us to check. I think, though, that we've come to the end with the 5F0. So I'm going to look at, because I think that it's the last one, I'm going to look at 608. Where is this symbol referenced in the assembly? ASM, US, ST, RTOP, non-matchings. Yeah, we could look at matchings too. Look at star matchings. And I want to look at one line, no, let's say 3 lines after, and 1 line before. And what happened here? There's no reference to this? All right, so initialize entity. This symbol is being put into A0 register, which is the first argument of the function initialize entity. So we know that 50 or 05FC, sorry, is definitely an entity. This 0608, I didn't see any reference to it at all. It may be referenced in other data. So let's just look. Yeah, so it is referenced by other data, but that means it's not an init. So 608 is where the non-init data starts. And so that's going to be our next entry. So these are all segments that will eventually get assembled into the final file. And we know one of them is init. And eventually that will turn into a file that looks like this, which is a table of entity updates and then some initialization data. And we'll build just to make sure that I didn't screw anything up. But that's fine. And so if we go back to that 0 data, now that's going to end after just 373 lines. We'll have another new file called init. That's all that data. And then another file called like 608, which is just a file we haven't given a name to. Interesting. This data here, step and p underscore x, should actually be RO data. I'm going to try moving that into RO data and see if Splat complains. Oh, I need put a dot there. A dot means that it's coming from a C file. I think that will be beneficial later. I'm not sure why. This didn't get chosen for RO data. Constant strings like this are typically RO data. Let me get the music back. And then I think I'm going to call it a day. So we were working on the beginnings of the reverse keep. Do you want to see where these are? Yeah, so they're in a function. They should be read-only. Add these changes. I don't think I did anything. Oh, I did add a RTOP header. And I need to get rid of, when you import new things, it automatically gets added to your Git stash. So I want to get those out of there, and then I will commit this. So we got clouds done. No. Clock tower. And we got, let's see, tombstone done. Pretty nice. So if you're not familiar with the Castlevania Symphony of the Night decompilation project, you can go to soten.z.dev and you'll see progress on all the overlays that we've been working on. We finished top last week, and now we're working on RTOP. What? Oh, that's because I clicked on it, which means that it should screw me over and not show anything and not be repairable. So top, we finished last week. At the beginning, I showed you a bunch of the stuff from BO4, importing a lot of that data. We don't have progress tracking for the data yet. I'm working on that. We'll see if I can do something with that. You get a link to GitHub at the top that shows everything that we've been working on. Some of that is the same as what is in those graphs, just not over time. And so top should show you something similar. Funks should be at 100% there. I don't know why it's not yet. May or may not take a while to update. Oh no, there it goes. It was just my cache. And you'll also see all the things that we've not started. And that's very important because we got a ways to go, but we're pretty far. There's also a link to Discord at soten.z.dev, and you can join us in Discord and see what we've been working on. And if you need to or want to help, contribute, stop by. We can't teach you to code, but if you do know how to code, if you know anything about MIPS assembly, if you know how to run a debugger, if you know details about the game that maybe we haven't figured out yet or been told about, stop by. But that's all I got for you. Appreciate it. Thank you everybody on YouTube who showed up first time. Hopefully I'll be back if it worked out. And then, of course, thanks to everybody on Twitch. Dig Down Deep, Nasty Nate. I'll be back tomorrow. We're on the same time. Adios.